Everything we've done so far, though, all this VRMS leg to leg, it's all this approximation for what is actually going on, which is always in the time domain. So I'm going to show you a demonstration that I wrote. This is what's really going on. This is what three-phase actually is. Here's our VA, VB, and VC in green. When you add up all of these things together at any point in time, you can see big negative VC, smaller negative VA, VB, and we end up with zero. And no matter how that phase changes, we worked it out, John worked it out using phasor analysis, but you can see here just by doing simple math, if you add up these three things at any point in time, you'll always end up with zero. It's important that our loads stay evenly balanced between our VA, our VB, and our VC legs. Let's say that we had an uneven load. Let's say that in your three-phase power company, your three-phase power coming into a big commercial site, you ended up wanting to take off a little extra power from your VA leg for your lights. So if this is current, now our blue line gets extended just a little bit. And now we can see on our right side that when we add up our values, we're no longer at zero. And this would mean that by pulling in a little extra power, a little extra current on our light for our lights off the difference between, say, VA and ground, all of a sudden now we've got an unbalanced system, and now all of our motors are starting to pulse. In a power company, they would penalize us for this. Just like they would penalize us for not running at a power factor close enough to 1, they'll penalize you for having an uneven power draw between your A, B, and C legs. So as an engineer, if you saw this, you would want to spread your lighting load out between not only your A line, but also your B and C lines. And if you did it correctly, like this, you'd see you could recorrect it so that everything's evenly balanced, and your neutral line really does run very close to zero. That's called power balancing, the other important part of electrical engineering for power besides power factor correction. Any questions before we go?